first problem with the N1 methylated pseudouridine that they used was that it doesn't allow the mRNA sequence to be broken down. So it's just constant production of spike glycoprotein. The other problem, though, is that it evades immune detection. And that's the thing about pseudouridine, whether it's pseudouridine that your body makes, because your body does make pseudouridine, or whether it's this synthetic one that they've injected into, they all evade immune detection. So you have two major problems now with pseudouridine. You have the synthetic pseudouridine. You have the problem of it evading immune detection, but you also have the problem of it not being broken down readily. And that means incessant production of spike glycoprotein. Now, once your body is producing spike glycoprotein incessantly, it starts leading to hemagglutination, blood clotting, sudden death, myocarditis, pericarditis. It gets lodged in all the tissues. It can breaks down the blood-brain barrier. It leads to immune system dysregulation. It leads to nervous system dysregulation. It's just horrific. It's a wrecking ball. Inside of the cell, it breaks down mitochondria. Inside of the cell, it disrupts the nitric oxide pathway, among other cell signaling pathways. It's just a nightmare on every level. There couldn't have been if this was altruistic, which it's not, there couldn't have been a dumber thing to choose to use for mRNA than the spike glycoprotein. It's easily if you want to believe that people were just incompetent and stupid, it is literally the dumbest thing that someone could have done, which tells you none of these people are that incompetent or stupid. So this wasn't about that. And when you read Cattell and Carrico's work, dating back to really like 1998, maybe a little earlier than that, I don't know, but the last one I read from her was from 1998. Nowhere in her research does she talk about gene therapy. That therapy is not mentioned. It's always gene replacement. What they've been working on for all of these decades has not been therapy. It's been replacement of genes, modifying the human genome. And why? So that you can insert, in cases like this, bioweapons. And if you insert a bioweapon to someone, now you can hold them hostage. You have to do what I tell you, or I activate that bioweapon. Maybe 5G is the activating source, I don't know. But you have to, now you activate it, now you can hold everybody hostage. You can hold a gun to their head and call it freedom. That's essentially what's going on here. So what happens is now the body starts producing incessantly spike glycoprotein that we know to be disastrous. And when the body produces spike glycoprotein incessantly, it's going to cause an increase in histamine, an increase in interferon production, and an increase in tumor necrosis factor. Why? Because histamine is the body's first response for a pro-inflammatory effect, because the body's immune system is going to try to deal with this. Interferon is the body thinking that this is a viral infection, when it's not. It's an mRNA infection. It's not viral, though. So the body is trying to now block the mRNA from, or the suspected virus from replicating. Now, if you've ever had a night where you did get a little viral infection, a little bit of a flu, and you're laying in bed and you just can't get comfortable, you're like moving around, but you just can't fall asleep because your body's aching all over the place, that's interferon. Interferon is there to block viral replication, but it doesn't feel good. It feels like your whole body is aching, a bunch of myalgias, joint pain, you just can't get comfortable. Well, that's what a lot of people are going through. And if that only lasts for 2 or 3 days, it's not a big deal. It's when it's every single day for months and months and months and more than a year, that over time what happens is interferon activates another series of enzymes within the cell and especially within the mitochondria called pseudouridine enzymes. And now this spike glycoprotein has caused interferon to stay high for an excessive period of time. And the body now has activated pseudouridine enzymes. And what pseudouridine enzymes do is they transform uridine, which we need to be able to make proteins, right? To be able to decode what's going on in the mRNA and make the right proteins and the right amino acid sequences so they have the right shape and the right function. We need uridine for that. What happens when these pseudouridine enzymes turn on is uridine is biotransformed into pseudouridine. And so our body makes pseudouridine. But if this happens at the wrong places on transfer RNA, specifically the 34th, 35th, and 36th location where the anticodon is, for those that want to nerd out with me, when uridine gets flipped irreversibly into pseudouridine, because of these enzymes, because of that interferon, because of the spike glycoprotein, now what happens is you get massive protein synthesis error. You get maybe the mRNA says, I need a methionine, I need a phenylalanine, I need a lysine. Maybe that's the sequence. Methionine, phenylalanine, lysine. That's what the code says to be made. But because of pseudouridine being activated in the transfer RNA, what actually gets made is tyrosine, isoleucine, tyrosine, or something like that. So where the code was calling for a specific sequence of amino acids, you get a misread. Why? because the pseudouridine our body makes is a universal binder to every type of nucleoside out there. You see, uridine is supposed to only bind to adenosine. Guanosine is only supposed to bind to cytidine. So GC-UA, you probably remember that from biology way back when. UA, GC, that's the only binding patterns. But if uridine turns into pseudouridine because of interferon and these enzymes getting activated, now uridine can bind to adenosine, A, but it can also bind to G and to C. And as soon as you have that phenomenon occurring at the wrong position on a transfer RNA, what you get is massive protein synthesis error. Massive protein synthesis error that's incessant. And now what we get into is we get into cancer and we get into neurodegeneration, the two big things we see with people over time with the moderate and severe injuries, cancer and neurodegeneration. And when you have cancer and neurodegeneration now as a problem, guess what you're making? More pseudouridine, because now your body's producing even more interferon. And when that goes on, what you're dealing with is a runaway train and an accelerated turbo, if you will, cancer situation or turbo neurodegeneration. What's the cause? Spike glycoprotein incessantly being produced, and then interferon, and then the pseudouridine enzymes. But what makes it worse? The snowball effect of all of it. And so what's the answer? Well, that's terrible news, Dr. H. That is terrible news. If there was nothing we could do about that. Because what we started looking at was mitochondrial myopathy. Mitochondrial myopathy is where the mitochondria have protein structures called proton pumps. And those proton pumps ensure that the mitochondria can make energy in the form of ATP. Well, if those proton pumps, which are made of protein, if those are misshapen, well, now you don't have proton pumps. And if you don't have proton pumps, you don't have energy. That's mitochondrial myopathy. And that's what people who are saying, hey, I was holding up my arm for 2 seconds and it just built up a lot of lactic acid. That's what they're describing to us. It's not that they don't have the nutrients to do it. It's that their body, the mitochondria, physically cannot make energy because of protein synthesis errors caused by pseudouridine. That's my opinion today. So how do we fix that? Well, we have a great study that came out of Australia in October of 22. And it showed how you can use deoxyribonucleosides to help mitochondria start repairing the damage from the pseudouridine. How that you can give the body building blocks of nutrients, and what the body will do, especially in the mitochondria, the body will do is fix itself. Remember, man has never made anything that can fix itself, but that's all God makes, are things that can fix themselves, most notably at the cellular level. We're looking up all this horrible stuff on pseudouridine, right? And keep in mind, there's two forms of it. There's the form that they used in the damn shots, and then there's the endogenous form, the form that your body makes. And what's actually worse, in my opinion today, is the stuff your body makes. It wasn't an accident when we went and looked up pseudouridine that pseudouridine is a biomarker for all cancers and neurodegenerative conditions, right? That as pseudouridine levels rise, that's telling you that there's massive problems going on in the cell, that there's massive degeneration of the neurons, that there's massive tumor growth and things of that nature. So we have to be able to deal with that situation.